Yeah, thank you. My name is Axel Hendriks. I'm commercial director and one of the owners of Adex Group. We are a demolition deconstruction company in the Netherlands with circa 200 employees. And 10 years ago, we started to look at the buildings we had to demolish in a different way. We started to look at them as a mine of new materials instead of a pile of waste that had to be removed. And often when we talk about circularity and the reuse of building materials, it's about the environmental. It starts with the environmental side of the why. So I would like to start with the financial side of the why. This is a short introduction, then I'll skip to the practice. But this is the line of the increase of the prices of building materials in Holland, and we see a similar rise in Europe. As you can see, the prices of new building materials doubled in 20 years. But what's even more special, I think, is that the increase for the last few years, it increases by much more than the years before. So building materials, the prices of building materials are going up. And that's, of course, not very strange. We have to dig deeper and deeper to get to them. It gets harder to reach them, which means they get more expensive. But also the moving of materials becomes much more complicated. This is the blockage of the Suez Canal, I think in 2021. And this blocked one of the most important transporting routes from Asia to Europe. And it actually meant that building materials became much more scarce in Holland. So building companies had trouble reaching new building materials and it blocked building sites. And finally, we see that the CO2 gets priced into the new materials. So back in 2010, 5% of the CO2 got taxed to new building materials. In 2020, that was 15%, and in 2021, 20% of the building materials were taxed with CO2 tax. And this is actually increasing by the years. So our expectation is that building materials will become more and more expensive. And also throwing material away we see an increase of the price of throwing materials away as well. So this means that beside the environmental side of reusing and circularity, there's also a business case showing more and more. So this means a great opportunity to reuse more and more building materials. And if you put it in a scheme, we always show it like this. So you have a building on the left side. We take it apart, and then it basically will become three material streams. We have the direct reuse, which I will show a couple of examples for. That's the top stream. The middle stream is the reuse after you adapt the material slightly. I'll show a few examples of that as well. And the bottom stream is the recycling. I have one or two examples of those, but it's still, of course, also an important stream from the built environment. But the first thing that we do when we look at a building, as I said that before, we looked at the building as something that has to be removed and had to be trashed as soon as possible. And we started looking at buildings in a different way. So you start to look at the buildings like what's still in there, what's the technical specifications of the materials. And some things we do ourselves, and sometimes we contact other parties for it. So for instance, we don't know a lot about them, so we get an installation company that works with us to check the installation and to make a complete review of the installation, whether it's still suitable for reuse. But at first, inventory and quality check is a very important part of the whole scope, because then you can put your time and energy in the right materials, and the materials that are suitable for reuse, and you can leave the materials that are not suitable for reuse alone. I'll skip to this very shortly, but we make complete material passports of buildings more and more often. So what we do, and like I said, we look at the buildings as a material bank, basically. And with this passport, you register every material that's in this material bank. You log the material, but you also log all the technical specifications. And with this material passport, we can search for new applications of these used materials. So then to the execution, we have specialized disassembly teams. When we all started this, we came to the realization that deconstructing a building is something completely different than demolishing a building. So you need different people, different skills, different tools. So we founded specialized disassembly teams that basically work before the demolition teams. So they basically take everything out of a building which is suitable for reuse, which has been inventoried in the material passport, found it suitable for reuse, and then they can take it out. And we also use these teams to train people. It's the less dynamic phase of the whole demolition than the demolition phase itself. So this is a very suitable phase to train people which are new to the sector. And then to the examples, of course, because I think that's most interesting. So here I put a few examples of materials in the screen that we are often take out of a building to be reused. I can name them all, but it's roof tiles, carpet tiles, steel stairs, lighting fittings, sinks and toilets actually as well, but also isolation material. So what if you have to find a red line, it's basically that all the materials that are renewed often or stay in good shape in the building, such as isolation material, can be there for 20 years. It doesn't degenerate, it doesn't really wear and tear. So as long as it's being taken care of properly, you can take it out and you can place it back somewhere else. What's of course difficult is that you don't always know the technical specifications, but I'll get to that later on. But these are a few examples of direct reuse, so materials that are disassembly teams take out and that can be replaced somewhere directly. We do that via material hubs, so we try to sell the materials as soon as possible, of course, but you always have some storage and transportation, of course. So we have material hubs throughout the country, basically the same as warehouses of companies that sell new building materials, and we try to incorporate them as well. But I'll get back to that later as well. But then a lot of the material is not suitable for direct reuse. As you see, the wood on the left side, it's no, you can't put it back into a building like that. So we have to alter it a little bit. We have to adapt it a little bit, and we do most of that by hand. So as you can see, the wood on the left is still a mess. We take out all the nails and we saw it and we cut it until we have the wooden building materials that you see on the right. It's completely FSC certified as well. So we have all the certifications. We made clear agreements about technical specifications, even up to how many nail holes can be there in 1 meter of wood. It's maximum 3. But so you make a very clear agreement with the party that buys the material or that has to build with the material again about the technical specification that the wood or any other material can have. Now we do the same with a number of other materials as well. We do with gypsum board, we cut it out of the wall. So you basically put a frame against the wall, against the gypsum wall, and you cut out a new gypsum sheet, so to say. One other advantage of that method is that you can take out the isolation material, as you see behind on the picture. You can also take it out. You can also reuse it. So like this, you basically peel back a building, and you take out as many materials as possible. And as I said, sometimes you have to be a little bit creative. So a normal gypsum sheet is of course much bigger than the sheets that you see in this picture. But by cutting them like this, we get clean square sheets, and they can be reused in a new gypsum wall as a back layer. So when you do double gypsum, they first put down this layer, and then they put on a new layer of gypsum on the wall. The roofing tiles are, I think every office in Holland at least is filled with them. And by usage and by light, they change colors. So if you take them out and you put them back, you can see the color difference. So what we do is that we put a very thin paper-like sheet on top of them, and then they look as new. They keep their acoustic values. As you can see on the right, they look like brand new, but they're 99% old materials. So you alter them a little bit, but by that they keep their technical qualities and they look as good as new. And then the steel, I think Josse will also talk about this project. So I'll keep it quite short, but this is a project in Leiden, which was a big steel framed building. And what we did together with Josse and several other parties is that we cut out the steel structure and they rebuilt it with a new complete. They rebuilt the construction steel to a complete new building. So this also meant that we had to make a complete inventory of what's actually there. How can we repuzzle that into a new building? Apart from all the structural and other technical checks that you had to do before you can actually reuse the material. So it's actually a very cool puzzle, and it actually meant that we reused, I think, 160 tons of construction steel, if I'm not mistaken. But as I said, Josse will elaborate on it more. And then recycling. Of course, what we see is that a lot of the buildings that we demolished, they're not brand new, thankfully. They were never built in a circular way, so you can't take it completely apart. So also recycling is still a very important part of our work and what we do. This is actually the process of concrete. As you can see on the left, we make the concrete small and we recycle it into new raw materials that can be reused in concrete again. We see the same with plastic, but also with gypsum, and so recycling is also. I think recycling is also quite an important part of the circular economy, simply because of the fact that our buildings were never built in a circular way. And I think that brings me to the putting back the materials in the new buildings, because that's of course the most exciting stuff, the most exciting part. So what we see as you can take a building apart completely. You can adapt all the materials, but if you don't have a project to actually bring back the materials, then you're A, wasting a lot of money, but B, wasting a lot of time and energy. So the projects to bring back the materials are actually the most important part, when you ask me. So this is actually a project also of Josse and me. It's called Office Full of Waste, I think, if you translate it directly. And a lot of the materials that you see here in this picture, so the ceiling, both the white one as the greenish one, but also the carpeting, the walls that you see here, it's all reused, and it's all from one of our biggest projects in Amsterdam. And why I like this picture is because I still think it's a nice office. It doesn't look messy, it doesn't look used, it doesn't look wear and tear. It's a good office. So I think it's a good proof of that you can reuse materials, but still get a high worthy office or any other building. It doesn't always work that we find the project that the materials can go to directly. So we also sell a lot of the projects, the products that we take out, that we alter, that we produce. And as I said, we try to incorporate this as much as possible in the existing building column. So Popma is a very big store for wood, mostly wood, that deliver to the bigger building companies. So some of the wood, or most of the wood that we produce at our circular hub, we sell to Popma, and Popma sells it to their customers. This has the big advantage that the customers can keep their existing way of buying building materials, and they probably have to buy, I don't know, 20, 30 different types of wood. They can all buy them at the same store, and they can all be delivered in the same truck. So we don't set up like a parallel building column which has a special warehouse and special transportation and our own web shop and our own. I think that's very ineffective. So we try to collaborate with the existing column of supplies of building materials as well. That doesn't always work. So we do have an own web shop as well for what I call the specials. The materials that we don't have a fixed buyer for, or where we didn't succeed yet in incorporating it in the normal building column, we still have an own web shop as well, via which we sell, like I said, the specials. So we have a circular hub in Utrecht where we store these materials, where we alter the wood. Our wood workshop is there as well, and there we have a small store, so to say, where people can come and buy the building materials that they saw online. Yeah, what we see is that, and then this is one of my final slides. What we see is that circularity and the reuse of material, or maybe even sustainability in general, it gets more and more of a marketing term. Everybody is circular nowadays. Everybody is sustainable. Everybody is green. So what we think is very important, that we don't just say that we're circular, but that we make it very exact, and that everybody can check it as well. So with these material passport software that I showed you earlier, we can also show you exactly how much percentage of the building we reused and what we actually did with it, and also what the prevented CO2 emission is of the zone. And with this, we make it, we contribute as well to the CO2 goals of our customers. But we also prove what we do, and we prove that we lived up to our promises in the start. So then that was my presentation, or at least what I wanted to say today. Maybe there are some questions as well. Roman?
Yes, thank you so much, Axel. There are questions indeed. I'm just thinking that maybe. Okay, let's put few questions now, and then we will have extensive Q&A in the end after Josse.
Oh, yeah, sure.
So the specific questions to your presentations are: how do you evaluate metal structures for metal fatigue?
Yeah, we do that together with companies that are more technical into this material. Maybe Josse can talk a little bit about it as well.
Mm-hmm.
But in Holland, you have special laws and regulations since I think half a year for the reuse of steel, in particular. And basically, what you do, if you say it's simple, is that you test it. So you have to physically test the steel. But you don't have to test every single piece of steel anymore. So you can say, we tested one part and it's the same as these 100 other pieces. And for that, we can assume that the other 99 parts are good as well. So in very short, that's how it works. But we don't do it ourselves because we can't know everything about everything. So we work with specialized companies that run these tests for us.
Indeed. And do you get what's the question? Do you obtain quality certificates for the materials reused, or is it not required?
Sometimes it is required, and sometimes it isn't required. Like steel, of course, it's a structural material, so then you really have to check the material. You have to check the material. But isolation is another example. If we would sell the isolation to the new build of houses, and then you have to reach very high quality certification, and you have to prove the exact specifications of the material, and that's very difficult for us because we didn't produce the materials, we didn't put it there, we didn't maintain it, so we know very little about the material other than that we can see from the outside. So isolation materials we sell to structural projects where they value the isolating values of the materials, but they don't have to know it exactly. Like in smaller renovation projects, if somebody is building or renovating a house, then it's of course it's important that you isolate it, but you don't have to know exactly up to which level you isolate it. So we choose based on the material and the new place that it goes to, how much research we do to the technical specifications.
Yes, thank you so much. And this materials passports that you are creating, is it your own IT environment, or is it kind of software that you are buying?
It's we bought it, but we also altered it so that we can work with it there. But the basic, the basis of it all is from reuse materials. So it's a company here in Holland.
Okay, that's a good name.
We're not an IT company, so you have to know what you're good at.
Yes, indeed. Thank you so much. I think, well, we have many more questions, but I think we move the discussion towards the end because that would be right to do. Josse, over to you.
Yeah, good morning, all.
Good
Thanks
morning.
for having us.
Yeah, thank you for joining.
Let me share the screen. So hello everybody. My name is Josse Popma. I'm an architect. Our office is Popma Steege, and let me check. Yeah, switching. Last year we published a book called Reuse to Reduce, and it's about our practice, and it's going into the reuse of materials, but also definitely about like how to design with them and to work with the materials as an architect, and what it means for our profession and the shift of aesthetics, all those kind of topics. The book came about through a project called Biopartner 5 we did in Leiden. Axel just showed you a couple of images also. It's the one with the reuse of the steel. This is like a laboratory building, a multi-tenant laboratory, about 7,000 square meters in the Science Park of Leiden, where our office is also located. And it became the first building in the Netherlands that we call it Paris proof. It's an idea about diminishing the embodied carbon of buildings according to the budgets that were giving the Paris Agreement. This is all a bit a long story, so I will not go into that too much because I don't think that's really your biggest concern. So I'll try to just be a bit more inspiring in how to work with the materials. But it's good, I think, to know that for us this was kind of an also one of the tasks to work with these materials. One of the reasons, I think Axel also kind of explained this. But in the end, this book is also really about design and about the plea for reuse. Like it's been done for ages and ages. It's been a logical way of thinking. And if we are in Italy in summer, we look at all these beautiful buildings that were made out of the leftovers of previous times, and are inspired by the layers of history that are readable in these buildings. But somehow, if we get home and back to our normal practice, it's really difficult to keep thinking in this sort of more poetic way of working. We set up the book in 4 chapters, and the task is about why we do this. I will skip this for now. Then the second part is about the gathering, the collecting of the materials and how this process is going. The second is about assembling, how to bring those materials together again and construct with it. And the fourth is about the life of buildings, about actually how they adapt in over time and how they give a place for people and nature. But I will focus on the two middle chapters for now. So we said, actually what it turns out to is that there's also a new role for the architect to find these materials to work with. Like in an ideal new world, I think it will be a little bit like Axel just presented with the wood, that this wood is being collected by companies like that of Adex. They go to a supplier, and then the building industry can source from these suppliers again. But in the meantime, we kind of have to do it ourselves, project by project. So this is a photo of this bio partner at the moment that we cut the first bunch of steel columns, and we went there with our project managers and the steel engineer of the project and the builder of the project, and we started like the first visit to see what we were actually collecting. But in a way, you could really compare it to what, like in art history, people like Robert Rauschenberg were doing and called it like a city act. Each morning they left their studio in the morning and made a walk through the city to see what materials they were going to work with that day in their studio. And I think that's a lovely way to look at your surroundings and see all the possible materials that are available. Since there's so much already available and ready to use. And we compared it also to in a book with nice architectural examples throughout history, like Frank Gehry, who's trying to work with his local materials in his own house a long time ago, and be inspired by those materials to shape his house or shape his surroundings. In one way, I think it's really a pragmatic thing. There's just simply especially in the Netherlands and the western side of the world, I think people throw away way too easy, and there's an overshoot of materials, and so the pragmatical thing is to bring down the waste streams. At the other hand, there's also a big layer of symbolism, I think, in the reuse of materials, with an example of an old mausoleum in Turkey, where in architectural history you would call these reuse elements spolia, and they're actually kind of the show off of the materials that were they were looted or were won from the victories in conflict and built into their new palaces and into their new places as a sign of history, as a sort of ornament. I think these layers of history, like I said before, that's also really great part of working with these materials. And in the end, it's still, of course, always the task of an architect to make combinations and to think of how to select and how to what goes well together, and to make it into a new design. So we always feel like we're also a bit of curators of these materials, and we need to think of designing and how to reuse them and what are the potentials of materials. So then we come to the second part, which is, of course, it's nice if you gathered all these materials, but how to bring them back together to a whole and to a building. And I'm sorry. Often we get these questions like, yeah, this is a bit of an old-fashioned way of working. Like nowadays, buildings are made in factories, right? And it's all much more automated. And I think that's, of course, partly true, and will continue that way. But at the other hand, I think there's also always a lot of tailor-made, hoe zeg je dat? Like handwork needed. And I think these two things can go together quite well, right? You can sort of do the efficient work where it's smart to do it in factories, and we also just need the labor, and we have all these existing buildings, and we have the material, and we have the people, so we can truly combine these kind of ways of working, we believe. And so I think everybody kind of agrees with either doing it in the factory or in handwork, that we need to go back to a more smart way of constructing and focusing on connections that are deconnectable. Sorry, I'm sometimes used to do these presentations in Dutch, so I'm looking for words sometimes. Like you see on the right side the smart Japanese way of old-fashioned way of working, but these are actually houses that nowadays are taking apart again and shipped all over the world to resell as antiques almost, because they were so well made that these wood constructions can go in and taken apart again and be rebuilt. So meaning that we need to go away from these kind of buildings that are total monolithic. Everything is I don't know the English word for this, but in concrete you just pour everything together and it's one big monolith, and the only thing to adapt them is to totally crush them and go to smarter combinations. So we constantly say, like, working with these in this kind of way is like working as creating collages and making hybrid buildings, and use the materials where they are the best to use. And we always really are inspired by Shigeru Ban, the Japanese architect, who, for instance, made this pavilion. Probably some of you know him. He does a lot with paper construction, but for instance, in this German pavilion, really smart connectors in wood, small steel structures to raise the strength of the whole pavilion. So minimizing material use, but using the qualities of the material where it's best used, and by combining them, making a strong structure. And that also is a little bit about using old and new materials. It's not like a dogmatic thing, we would say, to only use existing materials, but just by combining them, they can truly get a new meaning. This is the steel structure that we just show, and from here on I wanted to go into a couple of cases to make it a little bit more concrete. So the first case would be the reuse of steel that we did for this bio partner. And I understand that these questions that were already asked, I will come back to it later, but this is the building as we found it. We were going to make a new building not so far away from this place, and we thought, okay, we're going to try to source our materials from this campus, from this science center in Leiden. So we went about and started to talk to Axel. We just met him at that moment, and but also to the university, who was the owner of this faculty, and that was about to be demolished. But when we got there, they already stripped the whole building from the inside, so we actually thought we were a little too late to reuse much. but at the other hand saw this steel structure and started fantasizing about if it would be possible to just reuse the whole steel structure of the building. And we went to investigate this with our construction engineer, and found out that, for instance, the floor heights were exactly the same as our new building, 4 meters from floor to floor, which is a quite standard, typical height for laboratories. And so we started to investigate the steel, and eventually took it apart in in small pieces. So actually, that's the start of the design, to think of how to cut the elements out of the building, right, and to be able to put them back in the new building. What would be the smart way? For instance, if you probably can see we took out these sort of T-shaped elements because of the strength of the connection of the beam and column. And we reused this typical strength of these elements in the new building, instead of all cutting them as single pieces. We brought them to the new location and made a small little factory, let's say, a little workshop at the site. So we didn't have to transport the steel all the way to a factory and have it adapted there, to save transport and make it a feasible project financially. And then it means you also have to go to other kind of techniques than you might use in a factory. So eventually all the steel has been bolted together in a new construction, instead of using weld connections, because of the welding is, you need to do it in a more controlled environment, and at the same time bolting the structure together always also means that in a new possible, in 20-30 years, if the building will be adapted or taken apart, the steel can be reused for a second time. And so it turned out into this is like a zoomed in piece of the building. You see some of the black parts are new like connecting pieces, let's say, like strengthening pieces of the connections, where we added extra columns to it. There's a lot to tell about it, but I will go a little bit, not go into detail too much. Here you see it in the final, in the end result. This is like the canteen of the building, which we kept the steel inside visible as much as possible. So we put on a coating, like a fire protective coating. So these are all kind of things to anticipate on when you start the project. When we found the steel, in the beginning, we immediately looked into this, if it would be possible to do this fire protective coating on used steel, got people involved. So in the gathering of the materials, we also always say, like, it's also gathering of parties that can help you out with these technical issues. As long as you, as an architect or designer, we have to think of all the steps that need to be taken in the design up to building it, and then collect the people you need to, and ask all the questions that need to be asked, and find out how it's possible, how you can make this idea possible. So it's a kind of different task than in a normal situation using new materials. I just wanted to say this. Axel also mentioned it shortly. After this project, some of the parties that were involved in national government, they used the project also to set up the lessons and new regulations of how to reuse steel. It's called NTA's. It's like a Dutch new standard. You can download it for free. It is in Dutch, so it's a bit difficult, but there are also quite some publications about the project explaining how we did it and the steps we took. But in this NTA, it gives you handvatten, yeah, like an explanation of what is needed to take these steps and reuse steel. So maybe someone can translate it and and you have some you can use it. Second case is actually the same project where we got to this donor building, as we call it, and each time we went there to work on the steel, we came about this giant hill of debris, of brick debris that came from the building, from little shafts. And each time we went there, we thought, yeah, we should be able to also reuse this material. How could we give this a new life? I thought this was funny to put this picture. I found actually when I was preparing the presentation, I took my girlfriend's car and just loaded a lot of this brick in, because I thought that, you know, that's kind of also part of this whole process. You take it and you take it home and you put a pile on in the studio and you think we should think of a way to reuse this, and eventually we got these kind of metal boxes are used a lot in the Netherlands for retaining walls, and we got a friend involved who's what's een kweker, like he's breeding plants. It's not the right word, but he so we got him in his hand is like a little ball of clay with a lot of seeds of Dutch wildflowers in it, and we put this into these boxes to see if we can make a new facade with this debris, but actually also make it a base for a green facade. And this is just in the beginning of when we just finished the project, and because the calcium that's in the mortar of the bricks is actually quite a good source for the planting, and now it grew to become, and so it's actually like new planting and flowers on the old brickwork. You can see a bit more of this on our website. There's also a movie showing the whole process of taking out all the materials and building it new. If you go actually to this and then to Biopartner 5, then you can see it. I don't know how much time we have. I could try to speed up a little bit.
No worries. We still have at least 10 minutes, and then
Okay.
Q&A. I can always
Okay,
start.
great. So this is another project. We called it an office full of waste, or actually our client called it office full of waste. It's for the Dutch government. Actually, the building, well, wat is nou weer het Rijksvastgoedbedrijf van Axel? The department that's taking care of all the governmental buildings, and they made a project for renovation to learn on reuse in renovation. So we won the competition, and then we had to sort of open up the building for a new way of working, their typical way of working, and at the same time reuse all the materials that we were taking out of the building and all the new materials that we would have to use for this new design. We were supposed to try and use as much as possible reclaimed materials. So we did this also together with Adex, and I will focus a little bit on the brick that we took out. This was a typical 80s office building with just a corridor with closed walls on both sides and small offices. and all walls were made in brick. You see on the right, it's actually a new wall that we made with cut out pieces of brick, because we wanted to open up this building, put more windows in it for on the inside, more light and more contact for future people that would work there. The openings that we made, we cut out the brick and reused that brick. Partly we did as a test to make it into in sort of new building blocks, about 1 meter by 1 meter. As you see, we kind of put yeah, I don't know how to say it in English. We covered them on both sides to sort of keep the brick together, build new walls with them, and then afterwards we took the cast off again. And while we did that process, which was of course a little bit complicated, but it worked well, we found out that the brick on the interior was actually, the mortar was really soft, and we could also just clean them up quite easily. And actually this is done more often in the Netherlands, also with exterior brick, to demolish buildings, but also take the bricks that are still complete or not broken, to clean them up and reuse them as brick again. So, and we did a similar thing with tiles. We had to take away a couple of floors that were covered with tiles, and actually we tested it and were able to quite easily take off the floor tiles and reuse them at places where we opened up a hallway that was also covered with tiles. So the hallway was getting wider, and we actually could use the old tiles to widen this hallway as if it had always been there. So the right part is new, the left part is the existing floor. So I was also quite happy with that, even though it's a bit laborious work. For the spatial quality, I think this is really great way of being able to connect old and new parts in the building, right? So like you also see here, like on the left, the new windows that I was talking about, where we cut the brick walls. Maybe should have showed this picture before. We brought out the concrete structure that was always really covered and made it into a new quality of the building. Yeah, and actually everything you see in the picture, there's no new materials used. The lighting is also reused from another building. The fire hoses, boxes that are on the left used to be in the building. We put it in the wall. We just used all the elements that were already there or from another building that was demolished. This is another link that I wanted to give to you. It's a Dutch, a European site where some Belgian and French and Dutch companies and research groups joined forces, and they show a lot of the techniques that you could use for recuperating materials. So for instance, also the cutting of these tiles, they have a nice documentation of how to do these kind of things and what materials are easy to reclaim and how to do this. So I think we share the presentation and or find another way to give you the links. But last case that I would like to show is the same project where we but then focus on the wood that we reclaimed. This is the building as we got there. It's an old military office. And so this, like Axel also showed you the inventory, that's kind of a process also for the design we take. So we first get there and you try to find and look into the qualities of the existing building, but also of the existing materials that are in there. So for instance, this wooden ceiling that did not conform to the new fire regulations in the Netherlands. So we needed to take it out from the client. But we thought, yeah, actually it doesn't look that great in this way, but it's a perfect material, so why not try to make a new ceiling out of it? So this is the end result. We took out the single pieces of the wood and brought it to a wood workshop that we work a lot as a partner of ours. We started testing it to yeah, I don't know the English words of this either, but to, let's say, to cut and sand the pieces and make them into new elements. Just simple tiles that can be placed in any standard hanging system. And in between the process of making the elements, we had the wood being treated for fire protection and give it a new coating. And eventually we brought all these little elements back to the building and made a new ceiling out of it. And actually this governmental organization was really enthusiastic about this, since they have about 650 existing military buildings from the 70s and 80s that need to be renovated, and it's a gigantic task. So they really want to use these kind of ideas to be able to do the renovation without constantly throwing away all the stuff that is already in there. So now we're going to try to scale up this idea. Actually, that was the whole idea of the project, to think in products, not only think in designing a building, but think of redesigning the elements of the building. And I think that's in general a really good way to work on this circular design, to focus on the elements of the building, like a door, like a wall, like a ceiling, like lighting, all these elements, and try to solve the reuse of these things one by one, to break down this big task into small tasks. And for each project, maybe one time it works to reuse the brick, maybe sometimes it works to reuse the steel. And with your client, always talk about the possibility to fall back in using new materials for an element. So if this wouldn't have worked with the wood ceiling, we could have used a different ceiling. It would, and then one of the 20 products that we thought of may not have reach the end goal, but then the other 19 would still work. So I think that's often a good way to also control the risks of this kind of way of working, to bring it back to all these small pieces and try to solve them one by one. There's another images of the end result, and I think what Axel also said, yeah, the whole goal was to make an office that has actually more character than a standard new office, and sort of celebrate the quality of these materials by combining them, by using a new color scheme. By adding light and space to the existing building. You can also see the lessons that were learned from this project. We made a website with our client, just launched. It's a long address, if you Google it on this kantoor voor afval, which means office full of waste, then you will find it. And we try to write out the lessons in a abbreviated form, but I think it's still quite informative. Yeah, that's actually my last slide for now.
Wow. Thank you so much, Josse. Indeed, fascinating. Some of the things you show are even I see for the first time. Let's move to questions. We have some more questions, and I will keep mine for maybe for later. Okay, the first one. So for how long does the deconstruction or demolition process prolongs if you do this circular approach with keeping secondary materials in comparison to the normal demolition?
Is the question to me?
No, I think it's to Axel more.
Okay.
Yeah.
Yeah, the honest answer is that we don't really get that much extra time. That's also one of the reasons that we have the specialized deconstruction teams, so that we can take it apart a bit from our regular process. So I'd say for a standard office building, it takes max 1 week extra. They just get a head start, and then we work in a train, so to say. So we first do the demolition of the deconstruction of the top floor, and then they go down each floor. In the demolition phase, they basically follow them. When it comes to the reuse of steel, especially if you want to reuse it, then it takes a little bit of extra time. So I'd say 20% extra time in deconstruction.
Yeah. Okay.
And you also put in more time and effort. So you invest more. So you have to put in more time, more effort. But the advantage is that you don't have to throw stuff away, but you actually can sell it in a way. So the extra investment should be repaid by the higher value of the materials that you take out. That's sometimes a challenge.
Yes, I can imagine. Especially it is a challenge in Ukraine, for instance. How do you calculate CO2? What is your methodology? Maybe you have a link to it.
Yeah. So what the system basically does, it looks at the material of the item. So if you have a window frame, it's made out of aluminium, and it's this much gram of aluminium, and then all the data when it comes to producing the aluminium is in the system, and it basically compares two scenarios. So our scenario is we take out the aluminium window frame, we transport it, maybe we clean it a little bit, and then we take it back. And the alternative is that you throw it away and that you melt it and you produce a new aluminium window frame. And those two scenarios get compared, and then the difference between the two is what shows up in our material passport.
Nice. Yeah. So basically, it's kind of life cycle assessment and compare.
Exactly.
Yeah.
Actually, sorry, Roman. I think I think if you would like to check in Belgian government set up a sort of free open source calculation program. It's called Totem. You can go to his website, and I think also the data used there, like the European milieu data, like the environmental data, are free to use from there. Of course, there are a lot of other programs, software that you could use, but
yeah, I can imagine. One click LCA, there is
exactly.
There are I think one can just Google whatever software fits his or her needs most. But I know that for Ukrainians, it's especially interesting. For instance, One Click LCA has provided now a free license for Ukrainian reconstruction related works.
Great.
So it's quite relevant. Yeah, thanks for presentation. Maybe I missed this information, but do you reuse concrete and concrete panels?
We try, and every now and then we get a customer which values circularity so much that he's willing to pay for it, because it's much more expensive, is the honest answer. So we did a very big project in Amsterdam where we demolished 6 very big jail towers. It was a very big jail, like a prison. So there we cut out a lot of concrete slabs, and they came back in the new building that was built there in a new.
Was it office building?
No, it's actually a complete residential area. So it's not one
Housing.
building. It's actually, that's why I was hesitating a little bit. I think they're building 7 or 8 new buildings, but they reuse these concrete walls as pavement. So it's not. It's not they didn't even kept a wall into making it a wall, but they reused it as big slabs of pavement. And I think it's the most expensive pavement you've ever seen. But it was circular. So really cutting out the concrete and reusing it happens every now and then, but it's not the most financially it's not the most efficient way to work. But it does happen every now and then. There was a big project, it's not ours, but it was in Arnhem, where they cut apart a complete concrete building, and they're planning on rebuilding a new building with it, but it still has to happen. But recycling building is becoming more and more accurate and more efficient as well. So recycling concrete into like foundation materials for under a road is very common and even obligated in Holland. But you see more and more applications where we can actually recycle the concrete into new concrete, and there's actually machines that claim to take out the cement as well as one of the fractions.
Yeah. By the way, we are starting such a pilot in Ukraine very soon in August, and it will last for almost 2 years. We will try to do that with the help of a Dutch company who claims to do that, as you said. Next one is, what is the cost of construction? I think he means circular construction versus new construction. It's more to Josse, I guess, like if you would be building just from new materials.
It's always the question. It's so depending on, I think that's part of the design task, right? To think of how to keep it within budgets. Let's say the steel structure in Biopartner, I think eventually that became about 10% more expensive than the new steel that we were supposed to put in there. At the same time, I think a lot of people put a lot of time in it, extra time that they didn't charge. So you don't do this because you want to build cheaper, right? It's really the idea of reusing the stuff that's already there instead of constantly using new material and taking it from putting it on the cost of the planet, let's say. Eventually, like for both Biopartner and from this office full of waste, the budget was fixed in the beginning, so we had to do it within this budget. So that's the task of the whole team, to find ways to balance the costs. Some things are a bit more expensive, some things are way less expensive because you don't have to pay for the materials that you are using, or it's easy to construct. So in that way, you have to spread out the costs over the whole project. To add one thing about concrete, we are working on a project right now where we are going to reuse concrete floors, and there's a big difference between the what we call kanaalplaat, like the hollow core elements. They are much easier to reuse because if you cut them, the structural quality stays the same. Instead of port, we call this breedplaatvloeren, like they're port floors. They're more difficult to reuse as floors. You can use them as walls or columns. So you move the structural quality. But if you would focus on the reuse of concrete, I would really focus on the hollow core plates. I don't know if they have been used a lot in Ukraine. No, this is a small
Which ones?
Yeah, we call them kanaalplaat, like they're prefab elements with the hollow cores in it. You know?
Yeah, I just don't know what is hollow cores. Is it prefab modules?
Yeah.
Is it bio-based, like is it straw-based or wood-based, or?
No, they're standard prefab concrete floors, but they're
Concrete.
massive, but they have air tubes in it. Oh man.
Okay. Well, I can imagine this is probably a bit
So
complicated material.
prefab elements are easier to reuse than slabs that have been poured in the work, right?
Yeah. Indeed. By the way, there is a question now. It really fits this timing about some specific materials that are in the building. For instance, let me find this question now. Yeah, how to manage modern waste material separation for further reuse or recycling? Yeah, or maybe just utilization. Because in Ukraine we have very popular walls made from foam concrete blocks. We have polystyrol insulation, plastic mass, gypsum concrete plasters, etc.
Yeah. When it comes to circularity and the reuse of building materials, we love old buildings because they're much more simple and you don't have everything that's glued or mixed, or it's a disaster for the reuse of materials. In Holland we have these type of isolation that you fill a wall completely with these small polystyrene balls. So when you break open the wall, they fly all through the neighborhood, and then everybody gets mad at us. But for the reuse of materials, everything that's glued together or can't be taken apart, or that's difficult to take apart, it's a very big problem. In Holland, we have big sorting factories, so all waste that we can't take apart on site, we put it in a mixed building waste container, and it goes into a big factory, and then they sort out 7 waste streams, so wood, metal, plastic, paper, stuff like that. But they still end up with a big pile of mixed waste that gets incinerated.
Yeah, but at least, I mean, in your case, it's still 7 streams, and then in the end, it's still heat, at least from incinerating.
Yeah.
In our case, it ends 2 stages before.
Yeah.
So it's just mixed construction waste container and landfill. And that's it. So we at least have to have those things, I guess.
And we also, that's why we also have to think about the way that we construct new buildings today. So we have to build the solutions of the future and not build new problems.
For instance, I don't know what's your attitude to PVC windows, but they have been in the list of toxic construction material by Cradle to Cradle for a long time, and still this is probably the only option of windows which is so much widespread in Ukraine, and nobody is even questioning them, because wood windows would be twice more expensive than PVC windows in Ukraine, and if you have this aluminum profiles, they are also much more expensive. So what's your attitude to these windows?
Yeah, I think you can recycle them down here. So what we do here is that we take, if we're talking about the same material, we take out the glass and we put the PVC apart, and then we can recycle it. But yeah, you do have to recycle it via a big factory, which pollutes. And so we prefer a wood because we can alter the wood by ourselves and make it into something new. So you can't often you can't directly reuse the window frame because isolation wise it doesn't really match the current demands. So we have to alter the material, and PVC or aluminium in that way. You can't really alter it. So wood you can alter it, you can adjust it to fit extra isolating glazing and stuff like that. Yeah. So it's not our favorite.
Same with
true.
with this office full of waste project, we put in new glass, which is like one panel used glass and one panel new glass, but all the wooden frames we could repair them, right? We could, and it's a building that was more than 40 years old, and we repaired all the wooden frames, and it can go on for another 40 years. So it's what Axel said, like, yeah, if you have the possibility, it's so good to build nowadays, to think of the future and be able to and make things that are repairable and are adjustable, right? And take care of stuff that's already is there, and work on educating people that can do this kind of jobs, because that's also in the Netherlands a little bit problematic that it's like they're real professions to be able to work with wood and to repair buildings, to renovation, to know how to repair stuff, and it's really important thing.
Yeah, the skills need to be trained, I guess.
Yeah.
Just a question to Axel to make sure about this what you call the rest of valve that goes to container and then to 7 streams. So when you load this mixed container, do you pay this kind of utilization thing or and how much is it?
That's a good question. I think if it's sortable waste, so if it's clean enough so that they can try to take out as many streams as possible, I think we pay €285 per ton. And if it's non-sortable, I think it's €370 per ton. And if it's not sortable, they take it directly to the dump. It gets dumped as one.
So not even to incinerator.
No.
Wow. Okay. But I guess these amounts are extremely low in your cases in comparison to 100% of materials.
I wish. Now, of course, most of our buildings are from concrete and bricks, so that's the biggest part. But like I said, our buildings were the buildings that we demolished. That we demolished, they were built 50, 40, 60 years ago. So they were never built considering circularity or that we have to be able to take it apart. So unfortunately, we do have quite some mixed building debris as well, of a building waste, yeah.
Yeah, thank you so much. So next question, what's the price of new bricks and what's the overall cost price of the reused bricks for comparison that can substitute new bricks?
I knew this. Because you actually have a few companies now starting in Holland that they clean used bricks, like that's a very old craftsmanship in Holland which completely died out, but you see it coming back now. So what we do is that we demolish the building with a crane, but then we put all the bricks on a big pile, and then guys come and by hand they take off all the mortar. So you can actually buy now used bricks, but I think they're at least 2 to 3 times more expensive than new bricks from the factory.
2 or 3 times.
Yeah.
Okay.
Yeah, but I think this is really the wrong way to think about it. Like at this moment, these bricks are more expensive because these are startup companies that are right, and the cheapest bricks that are done, they make the biggest waste production and energy consumption and water consumption and pollution. Like what Axel was saying, that this is hopefully getting more and more taxed, and it should not be so cheap. These other materials should not be so cheap. And if you have a building that you renovate or you need to demolish, you have this material available. So the question is, how can we develop industries that can be competitive to new materials, right? And not say, okay, it's more expensive, let's not do this. It is, or that would be how I would think about it. Like,
Yes.
there is an opportunity, and how can we get this to become more competitive instead of just not using the options.
And
Yeah.
one of the biggest challenges in Holland is that labor is super expensive, and the whole building, the whole production of building materials is super efficient. So the whole comparison is and this new circular way of working is as Josse said as well, it's still a startup, so it's not as efficient as the production of new bricks.
Yeah.
I can imagine that that's also different in the Ukraine, where labor is maybe a little bit less expensive than in Holland. Especially if you have to import a lot of building materials as well, then that means the new building materials will be more expensive. So maybe the business case is completely different in Ukraine.
Indeed, but I guess overall problem is that overall problem for circularity oriented businesses is that the labor tax is way too high if you want to like work on secondary materials. In your cases, at least the natural materials are taxed properly, so that you have this high price for new materials. In our case, it's extremely low, so you have still high tax on labor and very low cost on natural resources. That makes circularity a challenge. But still, there was a case in Ukraine when this Kyiv theater, the new theater, has been built in a historical district of Kyiv, and the facade bricks have been reused from 150-year-old building locally, and they were cleaned, and total price with shipment was about what was it back then? I think it was 2 hryvnias. It's like 0.08 euro cents per piece, and it was more than 10 times cheaper than the new one imported from abroad. Now I get comments in the chat that we can make secondary bricks, because we have also deconstruction companies online. We can make secondary bricks for 10 euro cents per piece. I don't know if it's cheap or expensive for you, but it's the current price, more or less. Let's move on to a few more and then we wrap up. How do you find clients? I think it's more to Axel based on what he said previously. How do you find clients who are willing to pay extra for circular construction?
I think we have to. I think we should not cling too much to the idea that circular construction or circular demolition is always more expensive. We do circular demolition for government, and sometimes they're willing to pay, or they value circular building more, so you simply are not allowed to demolish their building if you don't do it in a circular way, so that they don't even look at the traditional way of demolishing. But what you also see is that on more and more materials, and that was also the start of my presentation, on more and more materials, you see that the business case is actually getting better and better. Like gypsum, I think, is a good example. If you put gypsum in the mixed waste container, it's a very expensive waste stream to get rid of. While if you hand it in as a clean material stream that they can recycle, it's already much cheaper. And if you get to take out the complete gypsum sheets, you can actually sell those gypsum sheets. So, and the same for isolation. And so for more and more materials, you actually see that the business case is getting better and better. The wood as well. The thing we do with wood is actually budget neutral now. And we get to train people with the distance to the labor market. So there are other effects that are actually positively influencing the business case. So in answer to the question, the parties that are really willing to pay more for circular deconstruction is mainly government. But what you see more and more is that that it's actually cheaper to do partly. And then of course you don't do 100% circular, but we incorporate circular demolition in every project that we do now, not because customer ask or not because we like to waste money, but because it's the smart thing to do.
Indeed. Yeah, it is. And you mentioned government. Do you understand right that public procurement is the driver for circular innovation?
For when it comes to demolition, I think it's fair to say that it is, yeah. Social housing, government-owned buildings, yeah. I think they're quite an important driver for circular demolition. Yeah. That's
okay.
A lot of organizations that somehow have a social aspect to it. It's like we're working for universities. They have this beautiful slogan like practice what you teach. So if they in their faculties training students to be more future oriented and environmentally oriented, then they think, okay, we also need to bring this in our own practice. Same with social housing. But it's
yes, it's a very smart thing to do. It's noted now by me, but I hope that we can also motivate our government to follow the case. And now some final things. So the question to both of you: if the trend is to construct buildings from prefab elements, which in the future will be easier to dismantle and reuse, what alternative can there be found for Ukraine, where solid monolithic buildings are currently the safest, meaning the strikes from the air?
in what sense do you mean that would be more safe?
So when you have monolithic concrete and steel building, when a missile from Russia comes, the destruction is not that severe if you probably had, I don't know, prefab wooden or paper elements by Shigeru.
Yeah, maybe that's true. I really wouldn't know, and to be honest, like with the opening of this office full of waste, there was the head of the defense, department of their buildings, and he answered this kind of question he got from the audience and said, well, with current technology, we don't make our military buildings based on bomb protection anymore, because it's not doable anyway. And but that was kind of for their offices and their terminals and those kind of things. And I was kind of surprised by that answer. But yeah, I really don't. I have to say I'm not experienced in this.
Yeah.
Do you? What do you think about this? Is there a way to make buildings this protective? I understand for a cellar, right? Like for a shelter that you need this.
Do you ask me or Axel?
Yeah, no, you, Roma. Yeah.
Okay. Well, no. The short answer is no. But the thing is that if it's Yeah, it's complicated because if it's you don't have such buildings almost, and that's a good thing about Utrecht or Amsterdam. But we in Ukraine often have this very ugly 20+ story residential buildings where people live. They are monolithic. So when the missile comes, for instance, you get a lot of destruction. So maybe 3 or 4 floors get destructed, but the rest of the building stays there and it keeps the structure. So it doesn't fall. It doesn't, basically it keeps the rest of people safe. Although, of course, you have to go to the shelter when there is an air raid alarm. So people might be asking, given this experience and coming from this reality. So indeed, there is no alternative to concrete and steel when it comes to durability. But for me, your comment about the military and defense guy sounds also very fresh. It's really something probably to think about.
And you know the Shigeru Ban technique, he developed it for refugee housing in Japan because of the earthquakes, and he set up a stichting, like an NGO for refugee shelters, and they built with this paper tube. They made brilliant housing and all kind of schools and all kind of buildings in a very fast way, in a cheap way, in a reusable way, being able to be mobile and light to bring it to any places. It was created out of a disaster, and I think a lot of I don't want to be telling you how to do things, because I really know that I'm don't know anything about your situation, but I think sometimes these innovations do come from lack of sources or lack of opportunities, and so I think designers can sometimes give new opportunities by really looking at what is possible, right? What is available, what is needed, and how can we turn this over? And it's difficult, and it's maybe expensive, but if people don't charge all their time and do it for a new cost, then sometimes new innovations can be born, right? It's
Indeed.
that can be
Basically,
inspiring.
Shigeru Ban has come to Ukraine now with his project, and we will soon have this new surgery division hospital building from CLT. The first in Ukraine, over 3 floors, which is actually not allowed by Ukrainian law. So it will be an experiment. Well,
Great.
experiment in Ukraine. I mean, so he's, and because Shigeru Ban is an architect of this project, I think this is possible to have, because otherwise our probably bureaucrats would say, no.
Yeah.
It's not allowed, la la la. Thank you so much for the comment, and I want to finish on the positive note, just with this kind of funny question, but I think I think I'm still interested in it. So Axel, if the secondary wood has more than 3 nail holes in a meter, what do you do with it? Like, can't you still reuse it, or is it just that you cannot certify it?
Well, we can still reuse it. I think we produce 6 or 7 different types of building materials in our wood workshop. So we preferably make the small wooden beams that you saw in the picture, but with the wood that is not good enough, like you have this cassade of quality, and then from the low quality wood we make wooden blocks that they use, like when you have to make a foundation for a building. They drill in these long poles in the ground, at least in Holland, because our ground is very soft. And then these poles are made out of concrete, and you smack them in, And to prevent the pole from damaging, they put a wooden block in between. And they used to make these wooden blocks from new wood, and now we supply the company that puts in these concrete poles with blocks made from wood, which we can't use for anything else. So we always find a solution to reuse everything, but again, sometimes it's more high worthy than the other time. Yeah.
Yes, cool. Thank you so much, Axel. Thank you, Josse. It was a real pleasure to have you, and thank you everyone who has been with us more than 1 hour and a half. Stay safe, and see you next time.
Same to you, Roman. Thanks.
Thank
a
you.
lot.
Thank you so much.
See you again.
Bye bye.